All right, we're going to continue because the next two sections deal with functions. And as we're going to learn next class period, that there are a whole bunch of, there are 12 to 14 different types of basic functions that we deal with. So the first ones we're going to look at are linear functions. Basically, they're straight lines. There are four types of linear functions. The first type is a constant function. So where it passes some value k, the function equation would look like this, where k is some number. The second type of function goes through the origin, and that's called the identity function. The identity. And that function looks like this. So remember, f of x is the same thing as y. So this says is y equals x. If x is 1, y is 1. X is -3, y is -3. So it's a diagonal line, 45 degrees. The third type, which is not really a function because it fails the vertical line test, is a vertical line because remember, a function has to satisfy the vertical line test, which means there cannot be more than one y value for every x value. For every x, there's only one y. This one, for one x, there's infinite number of y's. This one looks like this, where k is some number, some constant number. And the last one is 4. Is all other functions. And that looks like this. And this is, when people say linear functions, this is usually the formula they think about. Y equals mx plus b. And that's what we're going to spend a lot of our time talking about. So let's look at these first. This one simply looks like, for example, y equals 3. Why would that be a horizontal line? There aren't any x's. Since there's no x's, we can't have an x-intercept. So it can't cross. So it can't be angled. It's got to be a horizontal line. Likewise, this one here. There's no y values in there, so it is only an x value. The identity is identity, it's y equals x.
Since we go past, we go to 0.00.
For this one, yes, because if x is 0, y is 0. So the identity function has to go through the origin. Actually, to be honest, that's the only one of these four that has to go through the origin. Yeah, if you have an identity function, it has to go through the origin, and it has to be this way. Because if for any x you give me, it has to be y, the same values. And from here, the linear function y equals mx plus b will be what we're going to start talking most of today on. In a linear equation, two things are readily known if we have them in this form. For example, if we had y equals 3x plus 2. So remember how we find the y-intercept? The two steps we need? First step is what? Set x equal to 0. Because we only want the y values. And then solve for y. So in this example, what's the y-intercept? Yeah, because if we had y equals 3 times 0, that becomes 0. So y equals 2. So that is the y-intercept. The constant is always the y-intercept. The constant value. In other words, it doesn't have an x or a y next to it. So that's what B represents. And since it's not a horizontal or vertical line or identity function, it has to have a slope. Because between any 2 points, we have x1, y1, x2, y2. So we can find a slope. That's what the M stands for, is the slope. Remember, we defined M as slope. So the slope in this equation is what? No. 3. Yes. It's actually supposed to be 3/1, because remember, a slope is rise over run. So you always want to have it into a fraction. And the y-intercept, which is B, is just 2. Actually, it's actually the location 0, 2, but it's 2 in the equation. Which helps us to graph this thing also. So if we were to graph this equation, first thing you want to do is plot the y-intercept. So it's at 0, 2. And then from the y-intercept, follow the slope. So from that point, what does my slope tell me to do?
Move over.
And remember, it's rise over run. It's vertical over, it's always to the right. So it's up 3 from this one, over 3, over 1, and there's a dot. Connect the dots, you're done. Okay, so let's look at example 1. Graph the function f of x equals negative 2/3 x plus 1. And then determine its slope. And that's what m is. So we could do that. What's the slope?
Negative 2 over 3.
Right, it's negative 2 over 3. It's only possible if you have y on one side equals the equation. It has to be in that format first. Okay, so then to graph it, what do we do? At where? Very good. At the y-intercept. And then what's the slope from there?
If you go down.
Yeah, since it's negative, remember, if it's positive, it goes up. If it's negative, it goes down. And the bottom always goes to the right. So this one, from that point, you go down to 1, 2, 3. And then connect the dots. Pretty straightforward. Find the slope, find the y-intercept, and graph. So the first thing we have to do is what? Yeah, right. Solve for y. So we have to move the 4x over. So we subtract 4x from both sides. 4 minus 4 is 0. Negative 4x plus 20. Since it's got a negative in front of it, I change all of the signs. So that negative 4 becomes a positive 4. Positive 20 becomes a negative 20. And then I divide each term by 5. 20 divided by 5 is 4. So there's my linear equation. Actually, what is your slope? 4 over 5. And the b, -4. Or if it's asking for the intercept, that. So the b value is -4, but the actual location is 0 that. So plot b. Follow M. And plot that point. And then connect the dots. All right, so the y-intercept is at -4. The slope says go up 4 over 5. There's the graph. Pretty straightforward. All right. A unique type of linear equation are horizontal and vertical lines. That's too big. Okay, what do you notice about these two sets of points? Yes, so in the first one, you have same y values. And on the second one, you have same x values. Let's find the slopes of both of these. Remember the formula for slope? Nope. That's the equation of a linear equation. Close though, because M is in there. We talked about it all last week. Remember, it's rise over run. So it's y2 minus y1 over x2, x1. Y2 minus y1, x2 minus x1. So let's label our points. This is x1, y1, x2, y2. X1, y1, x2, y2. Remember, the subscript, the number on the bottom represent which point it's related to. So what's y2?
Oh.
-3. Minus y1,
Negative.
y1 is -3. x2, x1. So we have two signs together. That's a multiplication. Negative times negative is so -3 plus 3 equals what? 5 minus 2. So the slope is it's 0. 0 divided by 3 is 0. Because this is going to be important. Let's look at this other side. y2 is 5 minus y1, x1, x2 minus x1. And again, here we have a multiplication that becomes a positive. 5 minus 2 is 3. -3 plus 3, 0. So if you have 0 on the bottom, what's the answer? Undefined. Because basically is how many times does 3 go into 0? It doesn't, 0 times. How many times can nothing go into something? Infinite ways. I can give you nothing forever. But I can't, if nothing's there, I can't give 3 to it. So if the slope is 0, that means you have the same y values. If the slope is undefined, that means you have the same x values. So let's see what the graphs look like. So here are the points. We have 2, -3. So we have 2 and 5, -3. So it's a horizontal line. So if you have the same y values in the points, or your slope is 0, it's a horizontal line. So all of these are interchangeable. If I say the line's horizontal, what does that give you? What do you know already? If I tell you the line's horizontal, that means the slope is 0. That means you have the same y values. What that means is our equation, the equation of the line, is y equals -3 in this case. It's if you have the same y values, that's the equation of the line. Y equals -3. So in the next one, we have -3, 2, -3, 5, which means we have the same x values. The slope is undefined. If we plot those points, we see that we have a vertical line. So these are interchangeable. If I say you have a vertical line, that means automatically it should tell you two things. The slope is undefined and the x values are the same. Or if I say the slope is undefined, it's going through this point, what's the equation? So if it's undefined, that means we have the same x values, that means it's a vertical line. All of these things are interchangeable. The equation of a line here is whatever the common value is. Like we said earlier, because you notice that if it's a horizontal line, it can't cross the x-axis. So since there's no x values, it can't cross the x-axis. So it can only have a y value since it's a horizontal line. It only crosses the y-axis. The vertical line only crosses the x-axis. Only crosses the y-axis. This one is only crosses x-axis. Now you see why I tell you that this is unique, because all four of these pieces of information tell you the same thing. If I give you an equation like this, it only has a y, so it only crosses the y-axis. The y-axis. It's a horizontal line. The slope is 0. So, the example 2. Graph these two equations. X equals -2 and y equals 5/2. Graph those two equations. Since it only has an x variable, can it cross the y-axis? No. So what kind of line is this? It's a vertical line. And since it goes through x, it's a vertical line. There's your graph. If you still don't see it, then we know we needed 2 points to find the graph. No matter what you pick for y, x is going to be -2. I could put any values, I want to there, but x is always going to be the same. So it's going to be a dot there and a dot there. Same logic in this other one. You don't have an x value, so it can't cross the x-axis, so it has to be horizontal. This is 2.5. So it's between 2 and 3. Same thing. No matter what x you give me, it's always going to be 5/2 on the y value. All right, so that's that part. Any questions? For some reason, the horizontal and vertical lines give people the most trouble because it's missing something. It's missing the rest of the equation. But that's all it really means. Okay. Give me the equation of the line for that graph. Very good. Y = 1. It's a horizontal line. It only goes through that point. So that's the equation. No matter what x you give me, y is always going to equal 1. All right, let's look at some applications. Of slope. Have you ever noticed when you're driving on the highway and you get to a turn that the turns on the highways are not flat? They're at an angle. 2%, 4%, 5%, 7%. Depending on the speed of the highway, the faster the speed, the more angle you need. If you ever went to Texas Motor Speedway, you'll see that those banks are like 30 degrees, 38 degrees. I mean, it's hard to walk up, but because cars are going so fast, it's pushing them against the ground. Now, what does this mean? If I say this is what's called a grade, when you have a tilt on a road. So what's looking here is here's the road, the turn. Let's say this is a 4%. 4% grade. What does that mean? What does percent mean to begin with? We use the term a lot, but what does it mean? It's actually two words. Per cent. How much is a cent? A penny? So it's per 100. So whenever you see a percent, that means 1/100. So a 4% means 4/100. Okay, now what does that mean? What it means is, remember, this is a slope. This is a slope. What it tells you is for every 4 feet it goes up, it goes out 100 feet. So that's what that's what they're saying. If it's a 7, that means for every 7 feet up, it goes out 100 feet. Again, so the bigger the number, the steeper it becomes. All right, let's look at example 3. Curb ramps. Curb ramps. Curb ramps provide independent access to sidewalks for those in wheelchairs. Guidelines for the grade of the curb ramp suggest a grade between 5.9% and 8.3%. A federal law states that every vertical rise of 1 foot requires a horizontal run of at least 12 feet. Find the grade of the ramp as shown in the figure below. I can give you a figure. So a curb is usually 6 inches. 6 inches and 10 feet. What is the grade of this ramp? It's usually 6 inches by 5 feet, but I'm making this a little easier for us. So the first thing we have to do is what? That's in inches, that's in feet. Grades are in feet over feet. So we have to convert these into feet. What is 6 inches? Half a foot or 0.5. Since it's percent, what this one looks like is the rise is 0.5 over 10 feet over feet. We need to get it so it's 100 feet on the bottom. So we have to multiply top and bottom by 10. So 0.5 times 10 is 5. So it's a 5% grade. So that's the only thing you have to do is make sure that the units you're using are the same. Because even if we went to inches, it would still give us the same number. Because it's the ratio that we're looking for. Example 4. The food stamp program. What this one says is this. The number of people participating in federal supplemental nutrition assistance program has increased from 17.2 million in 2000 to 47.6 million in 2013. Find the average rate of change in the number of people using food stamps from 2001 to 2013. So let's write down what they gave us. Is 17.2 million in 2000 to 47.6 million in 2013. That should be, this should be 2000, not 2001. So what's the average rate of change from 2000 to 2013? When we say average rate of change, What we're looking at here is instead of going from these number of years, we're looking at down to what it is, what happens per year. So do we have any formulas that can do that? Yes. The slope is the average rate of change. The formula for a slope is y2 minus y1, x2 minus x1. That's true, but whenever we talk about time, the time is always on the x-axis. Oops. So time is the x-axis and y is whatever we're looking at. So how do we go from here, So T1 would be the beginning year. What's the beginning year in this equation? So that's T1. What's Y1? Yeah, it's the amount that matches to that time. And time 2 is 2013. And this is Y2. So the rate of change, which is the slope, is Y2, which is 47.6 million, minus Y1, 17.2, divided by T2, which is 2013, minus 2000. So it's 30.4 over 13. And whatever that gives us, that's what the rate of change is. Because what it's going to tell us is the rate of change per year. So over 13 years, it changed 30.4. If we make that division, then it's going to give us the how much it changes per year. And since 13 doesn't go into 30, it's going to be some decimal. So far, so good. All right. Y equals mx plus b. That's whenever people talk about slope or the equation of a line, that's what they think about. What's the name of it? What is it? You're getting there, yes. Again, mathematicians aren't too ingenious. What does M represent? What does B represent? So it's a slope intercept formula. Actually, and there are actually 3 standard forms of linear equations. This one is called the slope intercept form. But let's go back to where it began. Three forms of linear equations. I even give you their names. The point slope form, the slope intercept form, and the standard form. The point slope formula, it deals with a point and it has to have a slope. So this equation looks like this. Now, can you see why they call it a point slope? I'll wait to write it down. Because it has a point, x1, y1, and it has a slope, m. We have the slope intercept up here, so it's y equals mx plus b. And then the last one, the standard form, looks like this. Where x and y are on the same side. And the only stipulation is the a value has to be positive. So if a is negative, change all the signs. All of these came from something we've done already. They all began from this. What is that? Exactly. It's the slope equation, except I put instead of the m on this side, I put on that side. It looks a little bit different. If you think about it, look at the names: point, slope, slope intercept. So it all begins from here. For example, so here's our first equation. That's the slope equation. Whenever you have a fraction and an equal sign, this is throughout the rest of this course. Whenever you have a fraction and equal sign, get rid of the fraction. How do we do that? Multiply both sides by the LCD, by the denominator. So I multiply both sides of the equation by the bottom. So the x2 minus x1, they cancel. So we have y2 minus y1, m times x2 minus x1. And remember, has to be an equation, so you have to have an x and y value in there. So we get rid of the x2, y2. So it just becomes y minus y1, m x minus x1. And that's our point slope formula. So far, so good. It started from the slope. Now, this next part, I need to put in some numbers so we know what we're looking at. So let's say that we have a point at 2, 3, and our slope is 5. Because to use this, we need to have a point and a slope. So plug those in there. This is x1 and y1. So we have y minus 3 equals 5, x minus 2. Plug in the point and slope and solve for y. So we have y minus 3. We have to get rid of the parentheses. So we distribute 5 times x is 5x. Positive times negative is negative. 5 times 2 is 10. Get the y by itself, I have to get rid of negative 3. So I add 3 to both sides. Y equals 5x. 10 is bigger than 3, it's negative. 10 minus 3 is 7. That brings us to our third type of equation, the slope intercept. Okay, so now from here, I have 7. Now move x and y to the same side. So we have to subtract 5x from both sides. We have negative 5x plus y equals negative 7. The coefficient of x must be positive. So we change all the signs. So it becomes 5x minus y equals positive 7. And that gives us our standard form. Our standard form is ax plus by equals c. So a is equal to 5. B is equal to negative 1. And c is equal to 7. So that's how we find all 3 forms of equations. The hardest part is just memorizing the name with the formula. Example 6. Given this equation, find the slope and y-intercept. So what's the slope? Negative 0.25. Very good. The slope is whatever is in front of the x. And the y-intercept? Very good. And the slope, the intercept is the constant term. Same thing for this one. Tell me the slope and the y-intercept. Nope. Because where would you find M and B? It has to be in this form first. Nope. Well, let's see. We have to solve for y first. So since everything's on one side, we have to get y by itself. Let's just move the y value. So we have 3x minus 7 equals 6y. Divide each term by 6. So we get y equals 3 divided by 6 is 1/2 minus 7/6. So now what are my slopes and y-intercepts? Since it's, remember, always try to leave, if it's given to you in fractions, leave the slope in fractions, because 0.5 wouldn't tell me anything. What this one tells me is I go up 1/2. So fractions are more descriptive to me. So yeah, so y has to be by itself first before you start giving those answers. Graph this equation. So what's the first thing I gotta do? Yep. Here's There's your steps. Plot B. So actually, the first step is make sure it's y equals mx plus b. Actually, the first step is put into y equals mx plus b. Then plot B, which is 4. 1, 2, 3, 4. It's the y-intercept. And then from B, follow the slope. The slope says go down 2. So down 2 over 3. 1, 2, 1, 2, 3. And connect the dots. That's all there is to graphing, linears. Application. Here's an example. Estimating adult height. There is no proven way to predict a child's adult height by linear function. Can be used, but a linear function can be used to estimate it, given the sum of the child's parents' heights. The adult height m in inches of a male child whose parents' total height is x inches can be estimated with this function. The adult height f in inches of a female child whose parents' height is x inches can be estimated by this. Estimate the height of a female child whose parents' total height is 135 inches. So we have a female child. So which formula do we use? The second one. And what do we put for x? Put it 135. So it's 0.5135 minus 2.5. So half of 135 is 60. Two, 62.5, no, 25. Yeah. So half 135. Half of 130 is 65. 67.5 minus 2.5, which is 65 even. That's pretty short. 65 inches? No. 12 times 672. 12. Oh, yeah. Yeah, midget. But yeah, that's it for that one. That's it for section 4.